Okay, today what we're going to be talking about is how to solve logarithms or exponentials without using a calculator. Like your whole goal today is to only use your mathematical brain and not any calculator. Okay, so how do we go about this? So I'm going to go right into tonight's homework, and tonight's homework is going to be 312 worksheet 1, evaluate logs and exponentials without a calculator. So the very first thing that you see on this problem number 1 is that you have a base of 4 and a base of 2. So your goal is to get your bases to be exactly the same. So I need to transfer this 4 base to be a base of a 2. So how do I go about doing that? Well, 4 is 2 squared. So right here, you're going to multiply exponents together to give you 2 to the 2x is equal to 2 to the x plus 3. Now that your bases are equal, you can go ahead and cancel those bases out, and you can make the exponents equal to one another and then simply solve for x. So that means x is equal to 3, and that problem is done. Okay? Next, same exact concept. Okay? So the very first thing we're going to do is we're going to say, hey, look at this. This is a fraction. That messes with my brain. So I need to make that not a fraction. So the way we make that not a fraction is by making that 100 to the negative 1, because we're moving it up to the top. Okay, so that doesn't help me still, because now look, my bases are still not the same. So how can I express 100 to be a base of 10? Well, 100 is the same thing as 10 squared. So that means I have 10 squared, which is 100, raised to the negative 1 power, raised to the x minus 3 power. So I'm simply going to multiply all of these together. So that's going to give me 10 to the 2x plus 4 is equal to 10 to the negative 2 times x minus 3. Now I have my bases being the same, so now all I have to do is simply cross them out. And I have 2x plus 4 is equal to negative 2 times x minus 3, and simply solve for x. So 2x plus 4 is equal to negative 2x plus 6. Solving for x, I'm going to go ahead and add 2x to both sides. This gives me a 4x plus 4 is equal to 6. Go ahead and subtract the 4, and I'm going to get 4x is equal to 2. Divide by 4. And reduce the fraction to get you x is equal to 1/2. And that's number 6. Okay? Continuing to do your homework for you, I have number 12. Number 12 says to evaluate, and I give you log base 10 of 0.0001. Set this thing equal to the value of y. Or you could do x, whatever you wanted to do. So I'm going to do x, so this is going to be 10, go across the equal sign, write it as an exponential, and this is what you have, okay? Well, now I have a base of 10 over here, but I have this nasty decimal. So that decimal is basically the same thing as what? The tenths, the hundredths, the thousandths, the 10,000ths. So that's 1 over 10,000, okay? Well, what is 1 over 10,000? Your brain could have immediately gone to scientific notation and said that that was 10x to the 10 to the negative 4. Why? Because you moved it over 4 places. You can skip the fraction completely, but it is 10 to the 4th. So therefore, x is equal to negative 4. Okay? Next, number 13. Number 13 is exactly the same concept, set it equal to x. My base is 1/2. I'm raising that across the equal sign to grab the exponent, and that is equal to 128. That 1/2 screws with our brain, so that means I'm going to go ahead and say that that is going to be 2 to the negative x is equal to 128. I need to express 128 with a base of 2. 2 to the first is 2, 2 squared is 4, 2 cubed is going to be 8. 2 to the 4th is 16. How am I doing this so fast? 2 times 4 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So what this means is 2 to the 7th power is 128. Cancel out your bases, so negative x is equal to 7, so x is equal to negative 7. Number 13, okay? Number 16, same thing, it's a log, set it equal to x. So now my base is the square root of 3, raised to the x power is equal to 27. What do I not like about this problem is the square root. My power is 1, my root is 2, so this is 3 to the 1/2 x, power over root, is equal to, I need my bases to match, so can I express 27 to be 3 to a power? Let's think about that. 3 to the first is 3, 3 squared is 9, 3 cubed is going to be 27, so that means this is 3 cubed. Cancel out the 3's, and I have 1/2 x is equal to 3, multiplied by 2, x is equal to 6. Okay? Keep going, number 17. Log base 27 of 9 is equal to x. My base is 27, my exponent's x, and this is 9. Now 27 and 9, I can't express 27 as a base of 9, but I can express them both as the same base, and that base can be a 3. So we know that 3 squared is 9, and we know that 3 cubed is 27. So this is 3 to the 3x is equal to 3 squared. At this point, cross off the bases, and I can set my exponents equal to each other to give you 2/3 equaling x. Okay? Number 20. Same exact thing, setting this equal to x. 1,000 to the x is equal to 10 to the 12th. Well, 10 is fine. 1,000, let's think about this. 10 to the first is 10. 10 squared is 100. 10 cubed is going to be 1,000. So this is 10 to the 3x is equal to 10 to the 12th. So 3x is equal to 12, and x is equal to 4. Okay? Number 26. The directions say solve for x by first converting each equation to an exponential. I'm telling you that if I give you a logarithm, which they are all logarithms, that I want you to think in an exponential, which means I want you to put them all as an exponential to solve it. Okay? So what this means is I have x, I go across the equal sign to grab my exponent, and this gives me 81. Well, how would I solve that? Well, if you would take this and go ahead and say, okay, well that means my power is going to be 4 and my root is going to be 3. How do I get rid of the cube root? To get rid of the cube root, I'm going to cube it. Well, that's going to make that a super big, crazy number. And again, we're doing this without a calculator. So I do not want to take 81 to the 3rd power. That's a super big number. But I do know that those cancel out, and that's going to give me x to the 4th is equal to 81 cubed. How do I get rid of the power of 4? The way I do that is by taking the 4th root. The 4th root makes a number smaller. So what we're going to do is cancel those out, and I'm going to go ahead and take the 4th root of 81, and then I'm going to cube it. Now listen very closely. The 4th root is taking the square root twice. So what's the square root of 81? If you answered 9, you were right. Now what is the square root of 9? It is 3. So what we're doing is taking the square root twice to give me 3, and then we're going to cube that to give me 27. Now I know many of you would have immediately did this calculation and then took the 4th root of it. And I want you to take the 4th root first and then cube it, okay? So that's how you do problem 26. Number 28. Same concept, square root of 3 raised to the x power is equal to 1/9. Couple things I don't like. I definitely don't like that there's a square root, and I definitely don't like that it's a fraction. So I'm going to fix both of those. I'm going to fix this by doing power over root, so that is going to be 3 to the 1/2 x is equal to 9 to the negative 1. Well, 9 is the same thing as 3 to the negative 2. So now cancel these out, and I have 1/2 x is equal to negative 2, multiplied by 2, and x is equal to negative 4. Number 32. I'm going to go ahead and write this as an exponential. 5 cubed is equal to 2x plus 5. Well, 5 times 5 is 25, and if I have 5 quarters in my hand, I have $1.25. Let's go ahead and subtract 5. 120 is equal to 2x. Divide by 2. 60 is equal to x. And the last problem I'm going to do for you is going to be problem 36. My base is going to be x cubed, and raising that to the 2/3 power is equal to 64. Okay? These two powers can be multiplied together to give you x squared. How do I solve x squared is equal to 64? I'm simply going to take the square root of both sides. So x is equal to, as soon as I do the square root, I must add the plus or minus there, and it is equal to 8. So what I've just taught you today is how to do exponential and logarithmic equations without using a calculator. Tonight's homework is going to be for you to finish this worksheet.